Good morning, everyone. This is Sean Dara from the Lighting Design Lab. Welcome to our latest webinar, Energy Management Systems Part 2. We will be going live with the webinar in just about 3 minutes. We're going to allow a few more people to wend their way through the sign-in process, and we will be back with you shortly. All right, good morning, everyone. We are going to get going. We'll allow other folks to filter in as they manage to on this bright, sunny Seattle morning. Welcome again to Energy Management Systems Part 2. I'm Sean Dara from the Lighting Design Lab. Just a couple of words for housekeeping before we get going. During this class, of course, as always, attendees will be muted. Sorry, we'd love to get a great discussion going, but it just doesn't work in this format. So please use the chat feature, or more accurately, the questions feature, to go ahead and submit questions. Your questions will be reviewed and curated as they come in. Sometimes questions may be addressed immediately. Sometimes questions may be deferred until a little bit later in the presentation, depending on the flow of the presentation and the questions. Now, there will be several online Slido polls in this class. Please go ahead and participate in those. And following the class, please take the short survey. That is really useful for us to be able to understand how we can best serve you, the audience, and give you the educational opportunities that most effectively help you. If you have any questions, you can reach out to lightingdesignlab@seattle.gov, or you can contact me directly. You will see my email address at the end, which is just sean.dara@seattle.gov. We are, of course, the Lighting Design Lab. We are a part of and powered by Seattle City Light. We have always been members of the City Light family. We, of course, work with anyone who has lighting and now lighting and building electrification questions, concerns, issues. We work with end-use customers, trade allies, design allies. Really, we try to span the range of folks who may have questions or may need educational opportunities or training. We, of course, have traditionally had 4 service territory areas, education and training like this. We evaluate new technologies, we provide tools and resources, and we try to aggregate information as much as we can for the community at large. And now I am going to actually stop sharing, and I am going to hand the presentation over to Michele and Diane. Michele Sagehorn will be teaching this morning's class, and Diane Rasmussen will be moderating and will be providing any kind of technical discussion with respect to questions and so forth. So please, once again, remember, ask your questions as they come up, and they'll get addressed accordingly. All right, have a great class, and I will be back at the end.
All right, good morning, everyone. Diane, do you want to say anything before we get started or before I dive in?
Yeah, I just wanted to remind everybody that I'm going to send out links using the chat that you can use to get to Slido, or you can get to the deck. But if you want to ask a question, please use the questions option instead, because that's where they'll sit until Michele is ready to answer them.
All right, well, welcome back, everybody. For any of you who maybe are new or weren't here last week, again, my name is Michele Sagehorn. I'm with Redcar Analytics, and I'll be your presenter today for this EMS class. Again, a quick brief intro. I've been in the industry of energy efficiency for a little over 15 years now, primarily working on commissioning. So I've had a lot of experience with different building management and energy management systems, and hopefully we'll continue to share what I'm seeing and some of my real lessons learned in today's presentation. So let's go ahead and take a look at our agenda. For today, we are going to get a little bit deeper into what an EMS looks like, look and feel of an EMS. Also discuss the qualities of an effective EMS, and then dive into some case studies. The key questions that hopefully we're answering through this presentation kind of remain the same as day one, and that's kind of finding what that value of that energy management system is and how to successfully implement and to use an energy management system. So we are going to start off again with a poll. So if you guys want to get that going right now, the Slido, that would be great. Love for you guys to participate. Just to kind of see who's out there, how everybody's feeling today. So I'll go ahead and get that poll active. Get everybody to kind of wake up and get ready. And then obviously I'd love to hear if you guys have any thoughts on today's presentation, any questions you might have that we want to start off with, or lingering from last week, or even just kind of what you're looking for, hopefully to answer today in today's presentation. Give everybody a minute. All right, got some activity. All right, I know we're getting short week this week. I'm getting towards the end, but yeah, let's see if we can get through here today. All right, let's check in if we got any questions yet. Okay, well, I'm going to leave that up there. Again, if anybody, I think we're going to pause in another second here, just again, if anybody has any questions, but let me just do a quick little recap from day one before we dive into everything today. So last week we talked about kind of the definition of an energy management system, and the simple term or definition is primarily a software platform that's used to collect, track, analyze, visualize, and control at times, and optimize energy use, right? And so we looked at a couple different examples of some energy management systems. Some of the things we kind of noted were that these were all kind of unique looking, and that each client tends to kind of customize and make that EMS specific to them and their goals and their needs. I know we dove in a little bit deeper into that UC Davis as well. And I think another point that we hopefully emphasized on day one was that, you know, an energy management system should be presenting data in a very visual way and making that data usable and actionable for its audience. And then we also talked about kind of the value of an EMS, or why would you need an EMS? And so beyond the obvious one of just energy efficiency and resulting in hopefully cost savings, the two other largest categories fall into code compliance and also just the choice to pursue sustainability and participate in possibly one of these certification processes. And we definitely are seeing that code compliance is becoming really a requirement for energy management systems, or some of the activities that need to be completed for code compliance really could use a tool like an energy management system to complete. And then the last thing we kind of touched on was we spent quite a bit of time talking about building management systems and the difference between them and energy management systems. And there's a couple of reasons why, and obviously for our own education and hopefully to also be able to share that with clients or people we deal with within our industry, because this is really, between these two systems, it's one of the most, you know, often interchanged systems. And, you know, again, thinking that we have a EMS when we actually have a BMS. But at the end of the day, we really define that a BMS at its core is really meant to, you know, maintain a building, schedule things, schedule maintenance, schedule occupancy, to be able to deal with failures, alarms, but also to have the system maintain temperature and comfort for occupants. Whereas an energy management system is taking all that data from that building management system, it's analyzing it, and again, showing it hopefully in a graphical or visual way and producing something of value. And, you know, like I said, today, you know, energy management systems are not perfect, but I still really believe that they're one of the best tools we have out there in the field to be able to help a building and maintain a building's performance. So let's go ahead and dive in a little bit deeper, but real quickly, one more chance here. I mean, there'll be plenty of chances, but just pause for a second to see if anybody has any questions. If not, we will dive
No
in.
questions right now. We have 3 participants.
Okay.
Just so you know that when you're doing your polls.
All right. Okay, so let's go ahead then and dive a little bit deeper. And, you know, at the end of the day, you know, we said an EMS has a lot of different flavors and different looks and feels. One of the most important things is the ability to be flexible and to be able to customize it. For example, a building management system, there's also a lot of different vendors out there, but you will see in the industry that there's predominantly 4 or 5 major players. And if you have a system that's the same as some other building from the same vendor, it's going to probably look and feel the same way. And although it can be customized a little bit, in general, it's not too different from one to the other, whereas an energy management system generally has much more ability to be customized and flexible, which is a great thing because it is important. You know, we definitely know that each client is different. They have different goals. They probably maintain the building differently. And of course, you know, buildings are constantly changing. To expect a building to stay the same for its life, which hopefully is around, you know, 50 years plus, it's probably unreasonable. Things are going to change, maybe the use of it, the systems being upgraded, and so on. So this is really the bottom line as far as your energy management system. And so as we discuss this, we want to talk about it in kind of 4 different categories that really are important for making a good or an effective EMS. And so we'll go into each of these categories from customization, data tagging, navigation, and visualization. So let's start with customization. Customization can mean a lot of different things. I mean, it can be as simple as putting your logo on there or the university school color scheme, or if a corporation would like to use a page to kind of just be informational to its employees. So there's a lot of different ways customization can come into play. And again, it's about having that ability for different organizations to have different metrics. What I'd like to do is kind of introduce you to another tool we use in the industry, and kind of relate it to customization here, and that's fault detection diagnostics. FDD is the acronym used. And what is it? Well, it's actually quite similar to analytic software, which we talked about on day one. You know, it is taking pieces of information, putting it in an equation, and then kind of spitting out a result. And when we talked about the analytics software, we used an economizer as an example, where it's looking a lot of different data points from temperatures to valve positions or damper positions, and then again, kind of saying whether or not your system is performing or in economizer mode when it should be, and hopefully saving energy. Well, this is kind of the same thing. It's a bit more manual, and if I would say it's maybe a distinction between it is that we're seeing a lot of fault detection diagnostics actually be implemented even at the BMS level, beyond just at your energy management system. And in fact, is also becoming a requirement, at least in the state of California, as a code requirement. It's already one for package units, and I can see it kind of expanding out from there. So let me go ahead and kind of just walk through an example. So I'm going to walk through one of the ones on the screen, the lower one where it says AHU MAT low. What that is the air handler mixed air temperature sensor low. And so don't worry about reading this chart, but ultimately you'll see some writing in red. That's the equation. And so it'll go through that process and continuously be looking at those conditions. And then when those conditions are met, it's going to tell you three different things. It's going to tell you first a description of what the issue is. The mixed air temperature is too low. That value of that sensor should be between the outside air temperature and the return air temperature. And then it goes even further to tell you recommended actions. Like here might be some things you might want to go and do next. So in this case, it says, why don't you go ahead and look at the trend data for all three of those different temperature sensors and look for anomalies or something that's unique in that data for the last week. And then it goes and tells you what the possible problems or diagnostics of that problem could be. In this case, it's probably most likely a sensor error. It could be broken, or maybe it's not calibrated anymore. And if you go and look at that trend data prior to going out to the field, you might even be able to tell which sensor is actually bad. So the intent behind a fault detection diagnostics is, again, not to be another alarm at, you know, something's failed. It's intended to be something to tell you if your system's working properly or not, and to give you some additional information to help you kind of troubleshoot. Sometimes it's actually pretty easy to find a problem, like, okay, something's not right here, but then to be able to dive in deeper and find the details and the possible solutions before there actually is a failure can be sometimes more challenging. So this is where this is kind of assisting in that. We're definitely finding it to be very popular with the facilities and maintenance staff for maintaining the building's efficiency. So how does this come into the, you know, customization? Well, there is a guideline out there for fault detection diagnostics in the industry, but right now it's only covering air handlers and VAV boxes. So it doesn't cover all the types of equipment that could be in your HVAC system, like a cooling tower or a chiller. So I had a client that actually had a radiant system, and they had never had one, and they really didn't know what to look for or how the system was supposed to be performing. And so they said, well, we really need this at our energy management system. And ultimately, we custom built some basically FDDs kind of in a spreadsheet like this, and then programmed it into their energy management system. So we were able to customize it for that specific building and that specific HVAC system. And that's something that's, again, important so that we can have solutions for every building and every system type. All right, let's go ahead and move on. Adaptability is really just a part of the customization because, again, things change. You know, we have different users who all need different data types sometimes. They have, again, different energy efficiency goals and again, different users. And that's may always be changing. There may be a renovation or equipment replacement. So again, just kind of re-emphasizing the importance of being able to use your system in a way to be able to adapt when things change. All right, let's talk about data tagging. So if you think of the word data tagging, what probably comes to mind is how we label something. Like, for example, we have a temperature sensor. Well, that's kind of vague, right? I mean, so what does that temperature sensor mean? Is it related to an air handler? Is it related to a VAV box, HVAC zone? You know, it doesn't give you a whole lot of information. You do know what it is, but probably not that much information. Well, data tagging is more than just consistently naming something a specific way. It's about associating additional information with it. So let me start off with an example. This is from a real project. In fact, it's from a project that we're going to do a case study on later in the presentation at Lawrence Berkeley National Lab. They, and I don't really remember why they were doing this exercise, but basically they wanted to look at all of the supply air pressures for all of their air handlers across their campus. And so the first thing was to go find that data. And so when they did that exercise, here's what they found. They basically found that that particular piece of data was labeled 19 different ways as they kind of went through the different buildings to find this information. So you can imagine that took them a decent amount of time and effort to just actually get the data, let alone analyze it for whatever reason they were. And they obviously realized that was a problem. So what you want to be able to do is, again, kind of make things a little bit more easy and more efficient to look for it. And so data tagging allows us to organize information and associate additional pieces of information, and also know exactly where the data is coming from. So that sensor or that temp sensor, we can associate with it like a geolocation, the actual building it's in, the room, and what piece of equipment it's either associated with or controlling to. That puts the data in a much larger context. The other thing I'll mention is that the industry in general is trying to standardize a lot of this tagging. There's some guidelines out there. I'll call them guidelines. Project Haystack and BRIC are some of the main players, and that's exactly for their purpose, is to kind of give some, here's a best practice of how you should go about this as far as labeling your information in your data. By using these established tags, it helps us avoid confusion, and it also creates this whole new world of analysis. It allows us to analyze data in a different ways than we ever could. So another great example of this is, let's just say we're at the same campus and we need to replace a chiller. It's at the end of its life, we need to replace it. So now we're able to search, let's do a search of all of the chillers on campus and see what has failed over the last year. So when we do that, we might associate a piece of information with a chiller, for example, the manufacturer or the model number. And so now what we might find as we kind of sort the data and look for this information is that most of the failures were one manufacturer. So when we do that, now we might be like, okay, that's great information. That might not be the manufacturer I'm going to buy in the future. So that's something that, you know, historically has not been done on most, you know, definitely not on building management systems, and often not on, even on energy management systems. But now by associating a lot of more data with a specific data point, we can do a lot more searching, and it can be extremely powerful. So when data is not tagged or labeled consistently, it obviously increases time and cost for the integration portion or the construction phase of the project. And obviously that's an issue, but beyond just the construction or installation phase, it also plays into being able to maintain a building. So one more example regarding the data tagging is two of the systems that are being integrated today on a regular basis is HVAC and your lighting system. And part of the reason is we are using the lighting system to actually control the HVAC for an energy efficiency measure. We will take the occupancy sensors and basically, let's say in a conference room, nobody's using it, occupancy sensor says it's vacant, and then we can turn our ventilation air off or down to a lower set point, as well as let our temperature set points kind of drift a little bit, make it a wider band. So we might let that room get a little hotter, a little colder than we would if we were actually occupied in the space. And that obviously saves energy. But obviously getting these two systems to actually work together is not that easy, even still today. Still struggle with it in the commissioning phase of the project. However, you know, there's plenty of steps to make these two systems talk to each other. But once we do get them talking, the controls contractor is able to bring in all these data points, and they actually kind of look or may look similar to some of these on the screen that you're looking at right now, I like to say it looks like a foreign language because it's usually just a bunch of letters and numbers that don't make any sense. It doesn't let me know that it's an occupancy sensor versus a photo sensor. And it surely doesn't let me know where it's located, you know, what building, what floor, what room. And so when you think about maintaining a building, you're always going to have maintenance or failures. So, you know, if I have to go replace an occupancy sensor, I have no idea where it's located and what room and so forth, let alone, again, it's required to be able to have this energy efficiency measure because we need to know where it's at so we can associate it with the right HVAC zone. So all in all, I would say data tagging is great for an EMS for multiple reasons. One, for being able to do a much deeper kind of search and find information, useful information, but also for the help of being able to consistently label and make that maintaining the building a lot easier for the facility staff. Okay, let's talk a little bit about navigation. So navigation is just like you would think. It's basically moving from one place to another, you know, getting to the correct information or to the problem quicker. And so we're using another example here. So similar, the screen on the left is a building management system that's showing a chilled water plant. And the one on the right is an energy management system. Obviously a lot more charts and graphs. And if you recall from day one, I showed you guys kind of a heat map, and we were able to look at kind of like all the VAV boxes in a building on one graph. And then you might be able to click on it and go directly to that VAV box that might be behaving badly, let's say, where the alternate would be going through the BMS and clicking through each VAV box screen until you actually found the one that was behaving badly, which could take you a long time if you had hundreds of zones in your building. So that's an example of, you know, bad navigation or inefficient navigation, where a lot of these energy management systems are moving towards having these nice, convenient like links. So if you were looking at a graph, let's say on the right, and let's just use the example of an economizer again, and it said you should be economizing right now, but you're not, you're able to click on that data or that graph, and it'll take you directly to that specific air handler, and it'll give you, you know, maybe some trend data or some more information that's directly related to the economizing process. That is considered good navigation, and a lot of EMS systems are doing that. Now, how do you know what, you know, because that's definitely not something you see a lot of vendors or softwares promoting, but it is an important, you know, capability of an energy management system, let's say. And so there's a couple ways you could go about it. Is most of the time, if you were going to procure an energy management system, they do give you an opportunity to have, like for a month, have like a free trial and kind of use one of theirs and kind of poke around and play with it. Or they might even let you see one of their real live customers, obviously a read-only kind of view, but that might be one option to kind of decide between different energy management systems as well as the navigation feature. But another thing I would say is that even if this isn't obvious when you purchase it or when you first install it, it kind of goes back to that whole customization, right? Once you use a system for a while, you start to know which things you use and which things you don't use. And therefore, you can kind of make those adjustments if your system is capable of customization. And so I just wanted to mention that because it definitely is a nice tool or capability of an energy management system. All right, let's go ahead and move into visualization. So visualization, again, is just kind of the way it sounds. It's a graphical representation of information and data. And using elements like charts, graphs, maps, those tools provide an accessible way to see and understand patterns in your data, trends, outliers, anomalies, spikes, all that kind of stuff that we're looking for, as well as to be able to display data in the best way possible. Some data looks better in, like the UC Davis one. When you look at those buildings and you look at it kind of in that map view, that's very effective. Where if we're looking at, you know, just energy use in the building month over month, we might want to look at that in a bar chart. Or if you were looking at energy by end use, maybe you want to see that in a pie chart. So there's definitely different ways to effectively, you know, deliver that information. And so the other thing I'll say about data visualization is that it's really almost essential when you need to analyze massive amounts of data and information. and be able to make data-driven decisions. You know, if you think about it, if any of you have ever stared at a massive spreadsheet and you're looking at all these numbers and values and you're trying to find a pattern or, you know, anomaly in that spreadsheet, it can be really challenging. I know I've done that many times myself. But then as soon as you kind of put it on a chart, you're going to hopefully see that spike, and then it becomes extremely obvious really quickly. And that's essentially what we're doing here. You know, a good visualization tells a story, it removes the noise from the data, and it highlights useful information. I like to say it's a storytelling with a purpose. Okay, so just to recap, these are, again, 4 categories or 4 things that I think are very important to be part of your energy management system. You know, the ability to be customized and configure it to the specific user and their goals. The data tagging, again, for the purpose of being able to do and compare data in very different ways than you normally would, as well as to provide a standard or consistency that will hopefully help you with maintaining the building. And then navigation, being able to get to that useful information a lot quicker. And then visualization, which is kind of similar, getting to that goal or that tackling the problems in a quicker manner. All right. So I know throughout day 1 and even a little bit today, we are talking about what are some of the capabilities of an energy management system. But I wanted to take a minute in this slide and really point them out clearly. And I'm going to point out 4 of what I consider to be the basics or maybe the standards. I would say most energy management systems have these capabilities. So let's go ahead and just kind of run through them quickly. Again, tracking energy use and identifying inefficiencies. Benchmarking your building's performance and identifying areas for improvement. Performing measurement and verification to track energy savings projects. And incorporating data quality verification for self-diagnostics of errors in the system. And that one might be like that fault detection diagnostics where we looked at that mixed air temperature. That's a good example of that. So these are, you know, like I said, some of the basic ones. There's definitely additional capabilities. For example, we do know that there's energy management systems out there that have supervisory controls where we can change set points and have a little bit of AI technology. We know that if we wanted to do like some deeper dives, like that example of the chiller and the data tagging, we might need a different system that has a little bit more capacity for massive amounts of data and to kind of do some of those searches, but that might not be necessary for a small, simple building. So again, there's definitely more tools and capabilities out there, but I would say, again, most energy management systems at minimum have the ability to do these 4 core things. Okay, now I did want to take a minute to just talk about this. Things to avoid, meaningless comparisons. You know, as an energy management system, it's very important to have actionable insights. We need to be able to act because that's really where change happens. And so I like to give this example, my personal example of a car that I used to have. I had an old beater car that I used to use for commuting. And when I would use that car, very frequently, the indicator light on the dashboard would come on and it would let me know that one of my tires had a low air pressure. But that was basically all it said. It didn't tell me the specific tire or how low or any other piece of information. Well, eventually that car broke down on me and I had to buy a new one. And so it was obviously a little more updated model, had some more bells and whistles. And after having that car for a year or two, eventually I had a similar situation happen where that indicator light came on, but now it told me a lot more information. It told me it was my right front tire and it gave me the PSI value of the tire pressure. And then it even went so far as to say, hey, it's below the recommended tire pressure, unsafe to drive. That is useful information. You can make a decision based on that, like, hey, I might need to get this fixed right away, or I'm not going to drive this vehicle today. I'm going to find another alternate way to wherever I'm going. Where that older car, that tire alert on that became just a useless annoyance to me. You know, it really was, that's all it was. And I can tell you that a lot of energy management systems or dashboards share information that's not useful, rather than giving us clear insights and direction. It can also kind of overwhelm you with too much noise and obscure what's important. And it definitely will probably create confusion and raise needless questions. So instead of being empowered with actionable insights, we end up ignoring the data completely, like I did. And that's clearly not what we're trying to do here. We're trying to make the data useful and actionable. So just something to be aware of. Okay, so let's go ahead and pause for a minute here, see if there's any questions at the moment.
Just a quick break in, as long as you're stopped. We have one participant, Linda Holte, who is having difficulty getting into the Slido. Just letting you know that there may be an issue with Slido moving forward.
Okay, I'll definitely take a look at that during our break here, guys. Or
I'm in.
Oh, go ahead,
I'm in
Diane.
Slido. I'm sorry. I'm in Slido. It seems to be fine. I don't see Linda on the list of attendees. Did she drop out?
She may have.
Okay. I put the link to Slido in the chat, so if that might help to get in there instead of, or else just going slido.com and putting in the EMS one.
Okay, we don't need to keep going on this. If anybody else has problem getting in, please let us know. Thanks.
All right.
Yep, there's no questions.
Okay. Why is this on my screen? Okay, let's try to, okay, what is going on here? Sorry, guys. There we go. Oof. All right, so we're gonna move into our next section here. What makes an effective EMS? All right, let's go ahead and move into this. So, quality of an effective EMS. There's definitely, these two categories are extremely important. So obviously today we definitely wanted to cover them. You know, when you're selecting an EMS, thinking of these two things, one, you know, who are going to be the users of the energy management system? And we'll go through the different types of users and show a couple of examples, but that's extremely important. Knowing who's going to use it helps you kind of define what tools and what capabilities you need, and how to make it effective, as well as defining your metrics and your key performance indicators. So we'll go through each of these in a little bit of detail. Let's start with our intended users. All right, so this is intended to be a little bit funny, but ultimately we have three different types of users here to kind of use as an example. And each of these users, for example, energy managers, facility personnel, and building users, are all going to have you know, different things that they're looking for out of an energy management system. You know, they have different responsibilities and different roles, and therefore they're going to need different tools and different screens or visualizations as well. So, and you know, when you're doing this, you can create a system for one or multiple, but it is again important to understand who is the audience. The one thing I will say is that all three of these, regardless if they have different roles and responsibilities, do need something the same. They all need actionable insights or actionable data presented to them. And so let's go ahead and talk about each one of these and see how we can make the data actionable for the different audiences. So we'll start first with our sustainability or energy manager. Now they're obviously going to generally be looking at more than one building, you know, a campus or maybe multiple campuses, facilities, and they often need to look at the data at a very high level because a lot of their responsibilities include reporting to upper management, tracking and evaluating their sustainability goals, you know, whatever the company has decided, are we doing good, bad, improving, and then of course making a business case for energy efficiency projects, and usually associating costs with that or a simple payback. So those are some of the things that are important to a sustainability or energy manager. And so again, we have our example of UC Davis, and can't help it, it is one of my favorites, but I think, you know, looking at the campus view like this and being able to see which buildings are the most energy intensive is something that would be very useful and actionable for a sustainability manager. But also the example we used earlier regarding the chillers and being able to see what manufacturer as far as failures, using that data tagging or in that way to be able to do searches for procurement and costs is also something that I could see being very useful for a sustainability manager. So that's a couple examples for that user. Now, when we think of our facilities personnel, again, they will be looking for something different. Sometimes they're staffed internally, sometimes they're outsourced, but they're definitely looking at the data in order to troubleshoot or fix issues. I'll also mention that this type of user is often extremely busy. They often are dealing with alarms, comfort complaints, maintenance. So again, if they can get the information in an efficient way or in a more actionable way that helps them get to the problem quicker, that's definitely better. Their responsibilities are managing and maintaining that building, from a comfort perspective, and making sure things continue to run. And they usually will play a role helping the sustainability manager kind of implement energy efficiency projects. In fact, they're generally the person who gets into the weeds. And so I think a great thing to kind of talk about is that fault detection diagnostics, because again, that's an example where we are giving them the opportunity to say, what is the diagnosis before actually even going out into the field? And that helps them be more efficient in their job. So that's a good example of how to make things a bit more actionable for them. Another one would be those heat maps, right? That's a way for them to look at the entire building, every VAV box in it, and to see which ones maybe an alarm or not meeting temperature on a regular basis. All right, and let's go ahead to our last user, which is our building user. This is one that's often overlooked, and that's unfortunate because building users play the largest role in how our buildings use energy. And unfortunately, they haven't always been allowed to kind of engage, but I'm definitely seeing more and more of this out there, and that's great because it is important. But what they're looking for is data that might be informational to inform them on behavioral changes. How can they help or impact the energy use within a building? Turning off lights, opening and closing windows, managing your plug loads. So to give a couple examples of these, I have a client that had a zero net energy building, and part of their HVAC strategy was at the right time was to use natural ventilation mode. So they had manual windows, they were not automated. And so they needed to be able to tell the employees when was the time that we are in natural ventilation mode. This happened to be a software company. So anyways, what they did is essentially when people would log into their computer, there would be like a page that would kind of give corporate business updates, information. But there was also this widget kind of in the right-hand upper corner that was essentially a red light or a green light. And so it was really simple to say green light, it's a good time to do natural ventilation and open your windows. Red, maybe not, it's hot, muggy, we're gonna have the air conditioning on, please close your windows. And that's something they use to kind of engage the building users. Another example is I had actually a contractor that I worked with that built their headquarters. They also were trying to be Z&E, and it was their first kind of Z&E project they were doing, and they really wanted their staff to be engaged and to understand what was going on. So they just kind of created this dashboard that was more like a storyboard that explained the building systems at a very high level, but it also kind of went into detail as to some of the things that people could do within the building that would help them achieve that goal. And so I found it to be very engaging. I mean, at the end of the day, if you do work with this user, you're going to create a sense of ownership, better understanding, and for them to be much more engaged. And I think ultimately that's what we want to do. So definitely want to consider them in the process as well. All right. So again, it's really important to kind of understand who your users are so that you can make sure you have the right tools and can customize your system to make sure you satisfy them. Let's go ahead and move into the defining key performance metrics. So a key performance indicator is a metric. I will tell you that I think that a metric needs to have three things. I think it needs these three things here. One, it needs to be important to the client. Two, it needs to be actionable. And three, it needs to be measurable. And how do you get to the, a KPI for a client? Or, well, I think it really revolves around asking a lot of questions. Asking questions usually can help us kind of narrow down what are the needs of the client, right? You might ask them, is this for one building or multiple? Or do you plan on expanding in the future? Plant expansion or new equipment? Are you changing how you're going to, use the space in the building? Would you be using this system to make purchasing decisions or really just to track energy? Those types of questions, you just kind of keep driving at them. In fact, usually we'll have kind of more like a questionnaire to start to ask those questions in the very, very early planning phases. So let me give you a couple examples of maybe a good KPI and then a bad one. So maybe I'll start with the bad one, actually. So very frequently on new construction projects, the engineering team or the design team will put out energy targets for a building. And sometimes, or actually a lot of times, what I see is them to throw something out there like this. Our energy target for this project is going to be 10% better than the California Title 24 Energy Code. Well, I'm not really sure what that value is. I'm not sure. I'm guessing you guys don't know either, but what is that? And how do we measure it? It's not really a tangible goal. On day one, we talked about EUI, energy use intensity, and that's your energy use over a 12-month rolling period divided by the square footage. That's a real number. And a lot of projects, the engineer or someone on the design team will or can do energy modeling and kind of predict what that's going to be. And at least it's a prediction. It's a number that we can measure and work towards, right? So that, again, was an example of something that was not measurable. On the flip side, if you had a zero net energy building, and I'll have to be honest, I really do enjoy working on those projects. And here's the main reason why, is because that metric, zero net energy, is obvious. We are going to be zero over a 12-month rolling period. We're going to produce as much as we consume. When you have a goal that's not only measurable, but that you can understand, people tend to rally around it, right? Everybody understands it, from the client to the building users, to the contractors, to the commissioning agent. And when that happens, people tend to be, again, more engaged, more helpful as far as working towards that goal. And it often is more, achievable at the end of the day. So again, I really do believe these three things are extremely important when you create a metric. All right, so now we're going to do a little activity, and we're going to go ahead and have you guys, there's going to be 2 links, and we'll have Diane put those in the chat. We're going to have you go take a look at the Berkeley Lab and some of their KPIs and how they're reporting on their energy management system. So just kind of poke around, play around, see what you see. We are going to have some reflection questions. And those will be in a Slido poll that we'd love for you guys to share with us at the end of this exercise. So those are, what are the key performance indicators for this institution? And maybe how are those KPIs either similar or different, or even just what are your observations around them? So let's see, let's go ahead and give this about, let's say about 8 minutes. Let's come back at like 10:57, and we'll kind of then engage in our Slido poll. So I'm going to go ahead and go on mute for a few minutes and let you guys take a look at this, and then start the survey. right, guys, if we want to kind of start wrapping that up, we have the Slido poll open. If you'd like to share some of your observations, that'd be great. Give it another minute here and I'll kind of, I'll start sharing maybe some of mine as well. Okay, well, I'll start kind of, if you guys want to participate, you can, and I'll just go ahead and kind of start sharing some things that I noticed. So with this particular client, to me, it looked like they have a lot of different goals that they are tracking, right? This dashboard or EMS looks like to me that it's intended to be kind of forward facing for the public, for the employees on campus, but again, maybe even at the energy sustainability manager level, very high level reporting. The other thing that I noticed was that they have a lot of different metrics there, beyond just energy. They have waste diversion, ones that are specifically related to climate change goals, water. So just a whole bunch of different sustainability goals. And they're able to, do that on, again, an energy management system. One of the other things that they're using for this particular screen is a software called Tableau. We often use it at our company, but the main reason for me mentioning it is that to me, this site actually has changed quite a bit from the last time I've been on it. And you have the ability to kind of change some different things from, different fiscal year and different things and kind of play with it. Again, the ability to customize it and change is kind of where I was going with that, because obviously, like I said, it's changed from the last time I've been on there. And whether that's because they wanted to show more information or if they wanted to change some of their goals, they definitely have created a system that they can do that in. So those were some of my main takeaways. And we will actually talk about LB&L a little bit later in a case study as well. So let's go ahead and kind of move on and finish up this last section. So I guess, kind of just getting back to KPIs and how to get to the right KPIs for a client. We mentioned that just asking a lot of questions, and that's kind of essentially what we do at Redcar. So just to kind of share some of how we approach it with the client is we generally do have kind of a template of questions we start with and kind of ask and hopefully dive a little bit deeper and so forth. Doesn't mean that we don't need to engage other parties. Like I said, sometimes getting actual once we've kind of identified those goals, we may need to get the engineer or the right people in to kind of actually set targets for them. But again, just kind of starting with some of those basic questions can really help narrow down what you're looking for or what you need. This last poll here was really just to kind of ask you guys to think about, if you were dealing with a client, what would be maybe a question you might ask them to build an effective EMS. So if you guys, I'll give you guys a minute to see if anybody would like to participate in this one. And then I think we're about ready to head into break. So I'll give this a minute and then we'll give you guys a little break. All right, well, I will leave this poll active if anybody does want to, like I said, participate, but why don't we go ahead and break and come back at 11:10, guys. So we'll meet back here at 11:10. Thank you. All right, guys, welcome back. We have everybody back from break. Let's go ahead and start into our next session, which is our case studies. So I can share with you some real life projects. Definitely like this section here. So let's start off with one. This one is a Half Moon Bay Library. This is here in California. It's located along the coast, so it has a very temperate climate where this library is located. It is a new construction project that was completed in 2018, and that's ultimately when they opened to the public. It's a pretty small project. It's 25,000 square feet. It's 2 stories. They did achieve a LEED Gold certification, and they had the target to be a Z&E building. So when they launched in 2018, obviously they've been open for a couple of years now. Unfortunately, they had not achieved zero net energy yet. But actually, I started this project, I was the original commissioning agent through the construction phase. And then the client reached back out to me about a year ago and said they would like to re-engage, and they were looking for a little bit of assistance to be able to achieve that Z&E target or goal. So this has been a great opportunity for myself included to kind of be part of this process and help them get there. And so we are actually 11 months into this process, and we, I can say with probably 99% certainty they are going to achieve it, although I can't maybe officially say that yet. So it's a really great accomplishment, and I'm going to share some of that with you here in a minute. A little bit more about the building itself. It definitely has some unique mechanical systems. It has an in-slab radiant heating only. So there's actually no mechanical cooling for this building, partly because of the climate. They also have implemented some features like natural ventilation. In this case, for this particular building, they actually have a combination of manual windows and actually automated windows. They also have automated shades. And they do what's called a night purge, where they basically open these windows, automated windows, turn fans on, and kind of suck in that cool outside air to cool down the building and that thermal mass to kind of prepare for the next day that is kind of anticipated to be, if it's anticipated to be hot outside. And that's kind of how they deal with cooling. They also have these heat recovery ventilators, and they have integration with all sorts of things. They integrate with the electrical meters, the lighting system, the shades, the automated windows, the ceiling fans. So for such a small little building, it's pretty complex. As far as kind of their facility staff, they do have an on-site facility staff, not just for this building, but for their kind of their whole city. So they obviously are managing multiple buildings. But they do have this internal staff, and then they reach out to some specialists here and there as they need that to engage. So let me kind of just start by sharing their energy management system. So this is what it looks like today. I call this kind of a combination of a BMS and EMS because essentially they contracted the controls contractor to create this custom EMS or dashboard. It's literally kind of a link within their building management system. The one challenge though was during that construction phase, this was a really, really late decision to kind of move forward with an energy management system. In fact, they decided when the project was already into the construction phase. So unfortunately, I think it's a little bit because of that late start, there wasn't a whole bunch of clear direction on the content, the look and feel of what the EMS, what they were looking for. And there wasn't a clear direction on who the audience was that was going to use this EMS. Was it for the public? Was it for their engineering, or was it to track for zero net energy? And ultimately, I think if you would just spend a little time staring at this, you probably would be able to see some things that maybe didn't look right, or maybe could be displayed differently or better. And so I'm just going to kind of walk through some of those right now. So if you look at this and you start off in the left-hand upper corner, you will see the main electric demand. So that's the real-time energy in watts. And then you'll move over to the right and you see kWh for the current day average, and then the kW for the current day total. Now, this information is good. Like I said, it's not bad information, but I'm not really sure what to do with that. In my mind, that's not really actionable. It's only showing me one day. I have no idea if that's good or bad. I have no idea if I'm on track for zero net energy. or anything like that. So, you know, we're not even able to see kind of month over month kind of the energy use. And then as you kind of move down to the next row, you'll see basically the same thing, but now it says subpanel 1, real time, current day average, and then current day total. And then below that, you'll see subpanel 2. Well, the problem with that is I don't think anybody knows what's on subpanel 1 or 2. You know, is that your plug loads, maybe your lighting loads? Not really sure. So if you don't know what it is, it's probably never used, you know. That's just kind of the facts of it. One other thing you'll probably notice is that you don't see any solar data. There's no PV data on the screen whatsoever. So again, with it being a zero net energy building, we actually need to see that information. You know, we need to see the consumption of the building and the production, and ideally you would see it on the same dashboard. I mean, at the end of the day, you spend quite a bit of money. You would kind of expect that that information would be there and it'd be presented in a useful way. So unfortunately, that did not quite happen. Again, probably part of how just being kind of late to the project. Now the PV information is available, but we have to go to another web page and go look for it. And basically then we go download it, and then we would have to download the BMS data. And so what we did, Redcar Analytics, as we're helping them kind of achieve this goal, is we actually took those 2 streams of data and put them into that software Tableau that I mentioned earlier to present something in a useful way to the client. And I'm going to show you that in a minute. But a couple other things about this screen is you might also notice there's this chart over here that says floor temps. Because they also had never had a radiant system, they really didn't know what they wanted. They just knew that they wanted to understand the system better, and that they were a little concerned about comfort complaints and how to deal with them. So they decided maybe just putting the data on here and being able to see it might be helpful. In this case, I don't think it's providing them much help in that regard. So it could be presented in a different way to be a lot more effective. But I do understand maybe why it got initially put on this screen. And the other thing I'll say is that as part of this kind of 12-month period that I'm helping them achieve their goal, part of the end part of it is to update this dashboard. So hopefully we are going to update this to be a little bit more useful for them to be able to leave with them so that they can continue to track zero net energy in the future. So let's go ahead and take a look at, so this is essentially the chart that we've produced for them. And maybe it doesn't have all the information. We have a couple different charts we share with them on a monthly basis. But this is actually the real data from the building. And the blue is the main building meter, so that's the building consumption. And the yellow is the PV system, so that's our production. And we're looking at several months here. And again, looking at that data on the same chart lets us know if we're on track or not. One of the other things we do is that's not shown on here is just kind of have this net accumulator that says whether we're positive or not. And to kind of explain that a bit better, if you look at the month of June, you'll notice that the solar output is much higher than the consumption. And that's great. That's kind of what we would like to see on a regular basis. But as with most solar systems, when you get into the months like the winter months and you look at December and January, you will see that the building consumed more than it produced. And that's pretty typical. So the whole thing with Z&E is that this is over a 12-month period. So in June, if we go back to June and we say, well, that looks good, I don't see anything wrong. Well, we need to not only overproduce, but we would need to overproduce by a certain amount so that I like to say we put energy in the bank. We need to accumulate a certain amount so that when we have those months like December and January, that extra amount can go towards those months where we're not producing as much. So we will keep track of that kind of rolling net accumulator amount. The other thing that we do is we actually will compare the actual results, like again for June, let's just say, to the predicted results. And for PV, there's actually a lot of things that you can find online yourself. If you know your coordinates and a little bit about your information, you can go there and get an estimate of what your system should produce in the month of June based on local and historical weather data. And so by looking at the prediction is also helpful. A prediction always has a margin of error, but at least it tells us if it's grossly off. So one of the things we did before we started this 12-month period is we looked at the data just to see how it was coming in. And we noticed that the solar PV was quite a bit lower than what was predicted. And we kind of investigated that a bit further and realized that they hadn't cleaned or washed their solar panels for a couple of years. So obviously that's something that's important. And before we started this 12-month reporting period, we went in and did that activity. And then obviously they've added that to their regular yearly maintenance as well. But that's a good example of where also looking at kind of the predicted energy use kind of alerted us to something that seemed off. So that's kind of how we tracked the data over this 12-month period. One of the other things we put together for them was we went and investigated those panels, and we found out what was on all of those panels. And they did, the design did accommodate for segregating the loads at the electrical panel. So it wasn't too hard of an activity, but we were able to kind of identify the end uses and kind of display the data in this way. And this was also extremely helpful because we know in the years prior that this building didn't achieve net zero. So we knew we needed to make some changes and some energy efficiency improvements. And this is really where we kind of started from. So one of the things we did was on the HVAC side. You'll notice, kind of the value around 2,500. One thing I'll note before I tell you what we did is that obviously December, January was a little bit higher. That's because this is a heating only system, so it's kind of expected in those months. But you will see in the preceding months after we made a change, there was a pretty decent reduction. And so what we landed up doing is we found a couple things like the heat recovery ventilators were running 24/7. They weren't running to the building schedules, so that wasn't right. So we adjusted that. And then we also noted that the actual radiant floor, the set points were a lot higher than they needed to be. And so we made adjustments there. So some pretty easy changes. But what I really enjoyed about this was because the facility staff was involved in it, they were the ones who really came up with these efficiency measures. And the other thing I will note is that because we gave them these charts month over month consistently, they started to really understand them and be able to read them. And so when we made these changes, it was great for them to be able to see, wow, that really did impact, the energy use or this particular category of end uses. Another thing we did was on the lighting side. So lighting landed up being the largest category of energy use for this library, and that makes sense. There's a lot of lights in the library. In this case, what we found was that the light levels had just been generically set at like 90% of their output throughout the entire library. And so there's a lot of different areas within the library. Some of them are actually now like computer workstations. They don't need all that light. Or there was areas that just, were not meant for reading, and therefore they didn't all need to be the same light levels. So we went ahead and made those adjustments to the lighting system, and obviously saw a reduction there as well. And so those were some of the main changes we did. Again, not too challenging, but again, the team really kind of came in and participated. So our hopes is to be able to kind of put something like that similar to those charts on their dashboard at the end of the day so that they can kind of continue to monitor and use that information and continue to keep their building running at that performance. But yeah, my key takeaway from this particular example is that an EMS dashboard is most effective when it's configured to help the owners achieve their goals. And it was clear that they wanted to use that dashboard to track zero net energy. And so the one that I originally showed you clearly didn't do that. They also did want to share it with the public. And so I think even some of those graphs that I showed you guys, if we put that on their dashboard, is something that can be a lot easier to understand and explain to the general public if they were to come in and kind of look at it as well. All right. Let's go ahead and move into our second case study. So again, we're going to go back to LBNL. What I'm going to share with you is a building that I worked on. I worked on a couple different buildings on campus, but this particular one is called the Integrative Genomics Building, the IGB. It was completed in 2019, and it was a LEED Platinum building, zero carbon. It wasn't net zero, but very low energy intensity, specifically because it was a lab. There's 2 floors of laboratories and 2 floors of offices, and in total it was about 80,000 square feet. This building also had very sophisticated mechanical system. They had heat recovery on both the air and water side. They had multiple types of heat pumps, air source, water source. Radiant in slab was both heating and cooling, and they also had chilled beams. And of course, there was integration to numerous things like the lighting system, the electrical meters, shades, and so on. And the other thing to note is that for this building, it was the first one on their campus to have radiant heating and cooling, first one to have chilled beams, and also the first couple heat pumps they've had on the campus. So it was really a unique system for them as well. And as I mentioned, I started off doing commissioning, but I was asked to come back to work with LB&L has their own ongoing commissioning team. And basically what I was asked to do is help them with some outstanding issues that still were kind of lingering around, to also help them do a little bit of training on those systems and kind of, how are they intended to work and perform. And then the lastly, but not least, was to help them kind of ensure that the KPIs that they established in the early design phase kind of became a reality. And the one thing I will tell you about this client is they defined those key performance metrics on their own. They didn't need any help from anybody else. And they made some very specific ones for this building. They actually put them on the construction documents. And I had never seen that before. I can tell you it was extremely effective because it had a lot of great information that we often used in commissioning meetings with all the different subcontractors there, because it would say what the metric was, what instrumentation, hardware, software we needed, if there was an equation or how we needed to program it, the units of measurement, and where the data was going to be displayed and how it was going to be displayed, and then also who was ultimately responsible, if it was the electrical contractor, the controls, or mechanical, and so on. So it became extremely helpful, but to ensure that at the end of the project, we actually made sure that those metrics were, everything that needed to be there to measure and monitor them was there. And so that was, again, one of my roles here. But I do want to talk another second about the ongoing commissioning team. So on day one, I mentioned to you that it's not just about getting the EMS software, right? It is also about creating a process. Well, these guys do a great job at that. In fact, I would say that they're some of the best out there. They really know what they're doing here. And obviously, they've had years to kind of perfect it. But ultimately, they've taken a group of people, cross-discipline people. So the sustainability manager is part of the team. They have multiple mechanical and electrical engineers on campus as part of the team, facilities personnel, as well as an actual programmer that can program both the building management system as well as the energy management system. And what they did with this team is they took them away from their normal duties. So like that facilities personnel doesn't have to worry about comfort complaints and alarms and so forth. They are dedicated specifically to ongoing commissioning team. And kind of the way they work is every 30 days, they have a 30-day kind of rolling period. They each will be assigned an energy efficiency measure or project to work on, and they will go kind of troubleshoot it, try to come up with solutions, try to implement the solutions, and then evaluate whether they were successful or not. And if they were, then obviously measure how much energy savings they believe they've achieved or will achieve from that. So it's a really great process. And the other thing that, and you might not have noticed this when you were kind of poking around that example we used earlier, but I do want to note that that EMS, again, was probably meant to be high level. The EMS that's used by this ongoing commissioning team is got some different visualizations and different metrics that they're tracking than what you kind of just did in that last exercise. And for obvious reasons, they're kind of getting into the weeds and implementing these efficiency measures. So let's go ahead and look at one of their screens. So again, they love heat maps just as much as I do. And this is one that we actually landed up creating for this specific building. So part of the reason was they actually had a lot of these already for most of their buildings on campus, but they were all air-based systems. So they were VAV boxes. In this case, because it was a radiant building, that didn't quite apply. So again, we needed to make something customized for this specific building. And basically what this is looking at all of the radiant heating valves and whether they're open and closed and how long they're open and so forth. So you could see if a zone was always in heating mode, there might be something wrong with it. And so that's what they did, is they were able to make a custom one for this. And they do that a lot. Like if they go out and find an energy efficiency measure and they were successful in it, they might have their programmer come back and make a custom visualization for that energy efficiency measure. And there's a reason they do that, is not only to confirm that it was successful, but so that they can see that it's going to be persistent over time. And that's a big thing that, again, I think they're great at, because this doesn't come up very often. persistent energy savings is really where we want to be. It's just because we've implemented something and it's successful today doesn't mean a year from now it's still going to be successful. Things change, people put things in hand and override things or change set points. Unfortunately, things get messed with, and there's sometimes a lot of different hands in the cookie jar, or whatever you want to say. So this is a way for them to track if that energy savings is staying persistent over time. And they actually report out on that, which I think is excellent. So again, great process. The other thing that I learned from them is that by creating these screens like this, they also are trying to do a couple different things. They're trying to standardize across campus wherever they can so that all buildings look the same. And by doing that, that helps them train their team. Basically they're looking at the same screens over and over again every day, and they really start to learn how to use those screens, how to interpret the data, how to respond to it and make it actionable and go do something about it. And so it helps them with turnover and just again have their team be really efficient and effective. So that's something else I learned from them. I will say that in this process they taught me a lot of things and what was important to them and how they were able to achieve success here. So to me it was a great experience for myself. And again, they are able to use the customization, the visualization, they're kind of really hitting on all of those things we've talked about earlier. And so again, a key takeaway here is having a successful dashboards that are strategically organized with goals, implementation, and intended users in mind. Okay, so I'm going to pause real quick before going on to a couple more case studies, see if there's any questions.
Nothing in the questions pane.
Okay. All right, well, I will keep moving, and again, feel free at any time to enter any questions. All right, so this next case study, I like to say it's room for growth. Granted, all of these have lesson learned, but this one was also very unique. It was a large project. It's an office building, and so it's the office building kind of in the middle there, sandwiched between the two kind of older buildings. This happens to be on a corporate campus. And so on this corporate campus, they have, I believe, two different vendors for building management systems, and they actually have quite a few different energy management systems. And so you might wonder, well, why would we need another energy management system? That was kind of my question. Well, they have a lot of different groups, and those groups have different functions as well. And so what they found was that the sustainability team was using one energy management system. The campus engineers, mechanical and electrical engineers, were using a different one. And then the facility staff were also using a different one. And what they really wanted to do is to try to kind of combine it all and create one EMS that could be used for all of the audiences. So that was one of the goals of the project. But it was also, I guess most of the EMSs they were okay, but there was some features and some things they didn't like, and they were lacking a little bit of customization. So those were some of the main goals around it. But similar to that first project I shared with you, the decision to go with this EMS happened late, very, very late in the design and early construction phase. And what landed up happening is the people who kind of took the lead on this energy management was the engineers on the campus. And so they kind of took the lead, and we were not really able to engage the sustainability team or even the facilities team during this process. But their goal was still to kind of try to satisfy those audiences. But we did decide to build this dashboard from scratch. So from scratch is, you can imagine, it was quite an endeavor. And like I said, a lot of lesson learned from those. So let me go ahead and just share with you. This is actually the end result. So we did produce something of value, and there is some great information in here and some of the metrics that were important to them. But it was an extremely challenging process. The programmer that got hired was not an engineer. He was not familiar with buildings, building metrics, or any of the things that we actually landed up putting on this thing. So we had to be able to translate what we wanted to that person so that they could program it and make it visually look the way we wanted to. So I'm going to maybe flip back and forth. So this is kind of where we started. And I know this is a little bit of a busy thing, but ultimately Redcar was helping in this process as well. And so we were trying to kind of organize and understand what we needed out of this energy management system. So we did identify the different audiences we were trying to target and the information that would be useful to them. And so we kind of use this graphic and this kind of table to do that. And we even had some examples, like we showed up the UC Davis screen and some of the ones that we knew were some of the best practices out in the industry to get some ideas on visualizations. And it was quite an intense process to ask all these questions and get to the bottom of it. And from here, we actually then started to move into, okay, we've defined what metrics we want. How do we want to display that data? So how it looks on the screen, we actually did what's called wireframes, which is really us kind of making like either handwritten sketches or just drawing some and sharing that with the programmer to say, hey, we want this data to be a bar chart, or we want this data to be a trend, and we want these typical things on there. You'll notice there's like this little filter box up in the right-hand corner, that's so that we could compare, for example, if we wanted to compare last month to this month or yesterday to today on some of the metrics, we're able to do that. But we had to define all of that from scratch. None of it came packaged in any kind of software. So again, a very intense kind of process. It was a pilot project. The hopeful or intent was that if it was successful, it would be rolled out to the entire campus. Unfortunately, that's not what happened. But I will tell you that I think it was a great exercise for them, because they, at the end of the day, knew what they did or did not want. And what this landed up resulting in is that it was a dashboard for the engineers on campus. The engineers loved it, but when we rolled it out to the facilities personnel and to the sustainability team, they were kind of like, well, that's not what I'm interested in, or that's not what I want to see. And like the facilities people were like, I don't think this is helpful for me to do my job, and so forth. So that was kind of the feedback we got. And we realized that we kind of missed the boat on, making it effective for all the different audiences, which of course can be extremely challenging. But like I said, I think this gave them the opportunity to really try things out, know what they want, so that kind of moving forward as they roll something out to their entire campus, hopefully they'll get much closer to getting that EMS that will do all the things they need it to do. Okay, so we do have a poll here. If anybody does want to participate and share kind of what advice you would offer to clients to improve their EMS. And, that could be meant for this last example I just gave you, or for any of them really, from the Half Moon Bay to the LBNL one. But yeah, I would say just kind of think about that. If you were in the shoes of presenting that to a client, what might be something you would help to improve their EMS? And I will go ahead and just keep moving forward. I know we only have a couple participants. Again, so back to that example, that larger campus, that key takeaway was to focus on meeting the needs of the intended users in the building when building an EMS dashboard. Like I said, that was kind of, I think, probably the biggest takeaway or lesson learned from that particular thing. All right. Okay, so we have one last case study here. This one is a small office building. It is on a campus. We got involved in this project not as a commissioning agent, but actually as another function of our business at Redcar. We do a lot of research on existing buildings for the purpose of energy codes for the state of California. We will go in and kind of monitor and measure buildings to see if some of the energy efficiency measures that are dictated by code are actually implemented, if they're actually working, and if so, we try to quantify how much energy they're savings and get some feedback to those energy efficiency measures. So that's kind of what we were doing in this building. And so this client agreed to let us kind of study their building. While we were doing that, they took an interest to what we were doing, and they wanted to kind of see the data and kind of be pretty involved in it. This building, the systems in it was a variable refrigerant volume, VRF system, which is becoming actually quite popular as we're moving buildings towards electrification, because it's an easy way, or one of the ways, to have an all-electric building. And they had never used that system on their campus, and they were interested in kind of understanding how it worked, and how efficient it was. They were particularly interested to see if it was as efficient as the manufacturer stated, because they were thinking about using that on future buildings moving forward. So, and I guess the last thing to say is there was no BMS here. So what we had to do is we actually took our SenseWare, which I think I showed you guys on day one, but basically these Internet of Thing devices that connect to the cloud. And we had a kind of a monitoring plan where we went out and specifically monitored specific things that we were interested for research. So obviously their VRF system. We didn't monitor everything in the building, but we were able to be selective of what we were looking for. And we're, again, pretty non-invasive, but able to get the information we needed. And so what we landed up also doing as part of this process is presenting this data to them. We kind of made a little dashboard for them from the data that kind of looks like some of the other charts maybe you've seen, where we kind of broke it down by end use and showed them kind of the whole building energy use. And when we showed them this, they were really interested in this and they really loved it. You know, they ultimately said, this is great information. You know, we would like to continue to monitor this after you guys leave. You know, can you leave this equipment, or what would your suggestions be? And so we did talk to them a little bit about that. This project happens to, you know, it's not complete at the moment, but I will tell you that the client kind of recognized the value in that energy management system and the information it was providing to them, and just this little one that we kind of helped create for them. So they are pursuing finding a, you know, a better fit for a long-term solution. But they, like I said, were extremely involved and interested in this. And so I think it's just, again, important to kind of point this example out, because there definitely are a lot of buildings out there that don't have building management systems, or that are existing buildings, but they still are interested in their energy use and improving their energy use. And when we talk about a lot of these energy management systems out there, they really are kind of geared a lot of times to the larger clients or to campus level. But we're starting to see a shift, and we're definitely seeing more options out there for the smaller type of client, or again, clients without a BMS. And again, it's really important because we need solutions out there for everyone, you know, regardless of size and budget and so on, so that hopefully everybody will be tracking their energy use and trying to make an impact, or at least maintain their performance. So the key takeaway from here is that there are a lot of small buildings out there without BMSs, and there are effective cost solutions, or cost-effective solutions. All right. So we have one last exercise here, guys, today. I'm going to ask you guys to go ahead and do a quick little reading. This should be pretty quick. You don't have to read the whole thing, although I think when you get to the link, you can get this whole guideline here about becoming smarter about energy. Feel free to obviously download it. There's some great stuff in there beyond what we're going to look at today. But there is a section in here, dashboard the data. So would just like you to read that particular section. So if it looks like Diana already has got that in the chat. So great, thank you, Diane. And yeah, so if you guys want to take a look at that, that's on page 9. And while you're looking at it, just think of those reflection questions. You know, what are some of the potential benefits of submetering, and what roles can submetering play in a KPI, as a KPI in energy management? And so let's go ahead and give it about, you know, let's say about 7-8 minutes here, and then I'll check back in with you guys and we can kind of discuss any findings or thoughts. And I will go on mute. All right, guys, if we want to kind of finish up here, I'll leave the poll active, but I'll go ahead and start sharing maybe some of my observations. One of the things that kind of jumps out at me immediately is just them kind of identifying that the system that they had data mining or digging for data was very time intensive, and they were really looking for something that, again, very visual, easy to identify anomalies and things, changes in their building's performance or patterns of energy use, and creating these dashboards as a utilization tool to get to the information quicker. So it was also kind of noted in there just that they were using it for multiple audiences, right? For the site energy managers as well as for the actual employees. And I definitely like the story about the employees and the Hawthorne effect by just actually, again, engaging people, sharing the information with them, usually results in a positive thing without doing much or little, if anything at all. And so I definitely agree with that. And if you read a little bit further than that, it kind of leads itself to being a payback in itself by actually doing almost nothing. So again, a very quick payback. I think they showed 1.5 years, engaging their employees. And then obviously, if you use that system for a little bit more than just information, if you're going to try to do some tune-up or continuous commissioning, the impacts or the saving potential just goes up significantly. So sub-metering is definitely a great way. I mean, I think the best way to kind of describe it is that example we used at Half Moon Bay. That by putting the data in that way, it helped us identify that we needed to go work on the lighting, or we needed to go work on the HVAC, and those were the biggest, end users where we might have the biggest bang for our buck. And that's what helped us kind of make those decisions when we were doing that Z&E tracking. So sub-metering data is definitely great, and like you said, easy to kind of identify some patterns in your building's energy use and when you're using it. All right. So just kind of a recap today. Guys, I hope that we have answered all of your questions. We've hopefully answered what an energy management system is and why it's valuable, how to successfully implement and to use an EMS, or some of those important characteristics and capabilities of an energy management system. And, at the end of the day, energy management systems look a lot of different ways, and, can be very successful at identifying, organizing, and acting on the data. I know we have an exit survey, and I just, again, throw that out there if anybody has any last lingering questions.
Nothing in the question pane.
Okay. All right, and then I believe, Sean, you have a different exit survey, right? Is that something that they that we display or that they actually have access to at the moment? Anything to mention about that?
No. So everybody, thank you for coming to participate with us. Thank you very much to both Michele and Diane for sharing some very timely and very cogent information for us. I always really love to see case studies and how systems get implemented, right? So whether you are joining us today online, or you are one of the folks who are going to be reviewing this information later, just a couple of additional points here. Let me make myself an organizer. I should have been doing that while I was saying that, but I wasn't paying attention. There, that's better. Okay, so just a couple of additional points here. Upcoming classes from the Lighting Design Lab on our platform here. June 14th and 16th, we will have commercial refrigeration parts 1 and 2. June 21st and June 23rd, we will have adjustable speed, variable frequency drives and controllers, parts 1 and 2. And on July 14th, we will have a recap of what we've learned at Light Fair from both Armando Bradil and myself. Again, as always, our slide deck and the recording for this class can be found on our website. If you have any further questions, please go ahead and contact me directly, or go ahead to Lighting Design Lab at seattle.gov. Those will be fine. Of course, these educational opportunities are presented by the Lighting Design Lab and Seattle City Light. And when you slide out of the webinar, please go ahead and take our online survey, particularly giving us a sense of what additional educational materials and content you would like to see. So with all of that, once again, Diane and Michele, would you like a final word?
I just wanted to say thanks again, everybody. I definitely appreciate your participation.
Thank you.
All right, Diane, I will see you again for the commercial refrigeration. And Michele, you have our thanks for a great class. Everybody, have yourselves a lovely, lovely sunny Seattle afternoon.
Thank you. Bye.